So, welcome everyone to today's stream. And last streamed, I think, a week ago, and then I decided to stream every Monday, Wednesday, and Friday instead of trying to stream in consecutive days. So, also in this break, I also solved some of the CP31 questions. I think around 4 questions, and I was able to solve them without any problem. The status 15. So let's solve today's question. I think I last streamed this question, and then I solved this off stream, and this was easy. This was also easy. And this was also easy. So now today's question is this. Diff 3D question. Okay. Friends and restaurant. CP31. 1200. Let's read. Group of n friends decide to go to a restaurant. Each of the friends plan to order meals for currency. Okay. They have individual. They spend individual spend on meal, and y1, y2, y3 is their total money they have. Total money they have. So total 1 to n friends, and each friend will spend this much money on the meal, and they have total y1 money in the wallet. So total money after spend will be yi minus 6. Okay. The friend decided to split their visit into several days. So each day, some group of at least two friends, some group of at least two friends goes to the restaurant. Each of the friend visits restaurant no more than once. Hmm. So no overlap. Okay. These groups must satisfy the condition that the total budget of Each group must be not less than the amount of balls that the friend in the groups are going to spend at the restaurant. Okay. The sum of all xi values in the group must not exceed the sum of yi value in the group. Okay. Hmm. How can it exceed this number? What is the maximum number of days friends can visit the restaurant? Hmm. Let's write groups. Groups. Group size is greater than equal to 2. Each friend, each friend will belong to only one group. Hmm. Total budget of each group must be not less than. Okay. Hmm. For a group, summation x. Summation x. Hmm. Summation y. What is the maximum number of days? Let's see in this example. N is equal to 6 friends. They will spend this much. And total money they have. Okay. So here's the catch. The X can be greater than their total budget. Like he wants to spend 8 units of money, but he has total 5 units of money. So he will overspend and we will have to club this with the rich person who is saving more. Fifth and sixth friend can go to restaurant on the first day. They will spend okay. Hmm. The total budget is okay. Friends with index 245. 245. We'll have to write this one basic. Xi should be above and below directly. Yi should be there. So better for the better readability. 8, 3, 9, 2, 4, 5, and y is 5, 3, 1, 4, 5. So this person's group with this 2, 4, 5 groups Okay. He's saving, he's spending all. Okay. Hmm. It can be shown that they will not be able to form more groups. Okay. So the maximum number of groups. The friend can split into its two. Friends will visit a restaurant for maximum of 2 days. Hmm. Friends will visit the restaurant for maximum of 2 days. Note that the third friend, okay, third friend, he has only one money and will spend 9 times. Okay. Output maximum number of days the friend can visit the restaurant. Friends will visit the restaurant for maximum of 2 days. Output the maximum number of days. Hmm. Maximum number of groups. Okay, and this is for this particular question. Each day a group will visit, and we have to decide and make their groups so that they can have maximum number of days, or we can say maximum number of groups, because each group will visit in one day. Make Okay, he understood the question. Let's see the constraints. N is between this range. Xi and yi belongs to integer range. Okay. So in this case, accepted answers will be accepted time complexities of n log n square is not allowed. So how will we make the groups so that maximum number of groups are possible? If we send all friends, if we send all friends individually, case 1. If we send all friends on one, okay, at least 2 friends, okay, that condition. Okay. 3 4. Answer is 0. So why answer is 0? Because this person can go on comfortably, but this person will overspend, so we will have to compensate with, like, we will have to group this friend with some friend who will is either pretty rich or who is saving a lot of money. So he is spending all his amount. This will, so we cannot group him with this friend. Mm. And this person is also overspending by one. Let's write yi minus xi is their spending. So this is minus 1, this is minus 1, this is minus 2, this is 0. So no positive, no rich man. So, and also he will not be able to go alone because he need at least one friend more. So the answer is 0. Okay. So we will try to make groups of size 2 only. First we will try to make size of 2. If they can be made, then this will result in maximum number of days. Size 2, 2, 2, day 1, day 2, day 3, so on. And if we make some size 3, 2, 2, like we will expand the size to compensate for the budget only. Okay. Ideally we should be making size of 2, but if they are not able to pay their bills, then we will try to expand the group. Something like this. Let's see another test case. This, So delta will be, difference is minus 1, 0. This is 3. What are the possible groups we can make? This and this is possible. This and this is possible. Alone, single, he cannot go. And this 3 minus 1 equal to 2, which is greater than equal to 0. So this and this group is also possible because this friend will compensate for this friend. So only one is answer. What we can do, we do not have to send maximum number of friends. Okay. We just have to maximize the groups, and groups can consist of two friends. So we can leave him also, and still the answer is 2. Okay. What we can do is one of the probable answers will be, what if we left all, let's call this quantity delta. What if we left all negative delta? Then days possible will be delta. Okay, all positive delta can form two groups at max. Okay, sorry, each delta will make only one, will go only with one more friend to make the group valid. So delta, positive delta count, positive delta count upon 2. Okay, this will be one of the probable answers. And we can, because we will have to think this through greedily, and dp, I don't think this will go in dp, because then what will be the states? dp, greedy or dp, we can have that as a question mark. For now I am thinking of a greedy approach, greedy or dp. And right now I am pursuing this path. We can see, let's, if the greedy ideas fail, then I will have to switch to dp thinking. But I think this involves money, and a greedy person is always good with money. Greedy in the sense that he wants to save. So delta is delta yi minus xi. Okay. This is plus 1, so it's good. This is minus 1, bad. This is plus 1. This is plus 1. This is minus 1. This is plus 3. Okay. So if we take all positive deltas, their count will be 4, and they can go comfortably in this much. This is the minimum possible answer we can have. Minimum possible days. But we have to return maximum possible, so we will have to group positive deltas with negative deltas. So one group possible is they both can go. Okay. They both can go. Okay. And they both can also go. So what if we like to pointer? sort them in ascending order according to their deltas. Hmm. So we can have +1, -1, -1, +1, +1, +3. Hmm. This person will be a great spender. This person will be a great saver. So we will make the group if hmm, here we have some choices. Hmm, if positive sum greater than negative sum, then we will make this group I plus plus j minus minus. Okay, but if this negative was greater, like in this case, 1 2 3 4 case, so if we sort the deltas, -2, -1, -1, 0, this and this. I is here, J is. So 0 is not greater than -2. So we will try to think like this, that mm, one condition is the addition, like I plus plus j minus minus, and j will always be in region. J will always be in region where delta is greater than equal to 0, and I will be in region where delta is less than 0. And then we will try to go here, and we will be counting, including this in sum. So that will simulate a group of 3 with one a great spender and these two. Here it is negative, so this is also, this will this will quit from here due to this condition, delta should be greater than equal to 0. But if this one was positive, then we were able to make this, like, suppose this is +3. Let's write another one. Suppose this is the case, and we have our I here and j here. Hmm. So -2 and 1. So sum is less than, okay, sum is less than 1. So we will go to this direction and plus this. So we include this while we decrement our j because we didn't made our group. And so now sum is 2 and negative sum is -2, and they will be go happily. And once they go happily, we will start with the new group j minus minus and I plus plus, and they crossed each other. They are like on single person, and a single person will not be able to make group no matter what is his pending on delta. So okay. Hmm. If delta is 0, then we can only club them when delta is equal to 0, because if we club them here it does not matter. Okay, and days will remain same. Hmm. So if delta is equal to 0, we can only club delta 0 with delta 0. So their count will be delta is equal to 0 count upon 2 plus the answer we get from this process here. So this will be our answer. We have to maximize the days. Hmm. Have to maximize the days. So if this budget exceeds this, we'll automatically move to the next group, because we only want to make groups of size 2. If we make them of 3, we essentially extend the group to cover the expenses. And if we are already covering them in group of 2, then we do not need to extend the group. I think this is right. Hmm. Let's write this point. I think this is correct. I will have to test this, but we will try to make groups of 2 if budget allows. Then make group, otherwise we extend the group. Extend the group to okay. We extend the group to cover the expenses. So we also have two choices from here. Either we extend the group or we leave this person and move to a like a negative number, but a bigger number. So a better spender than the previous. We can also do this. Okay. Mm, or we have a choice. We leave that spender negative delta, bad spender will, and move to good spender. So what I mean is J++. We extend the group to cover the expenses. Here we are doing I minus minus, and if we make the group, then I plus I minus. I've written it wrong. Here I is here, J is here. Leave that person by I plus plus. We extend the group by J minus minus, and to confirm a group, we I plus plus and J minus minus. Hmm. And we increment the group uh, day count, which is equal to group count. Hmm. So we have a choice. How can we optimally greedily decide between this choice? If we start from a better spender in the first place, we start from the middle. We try to move in. If we start from the middle, he is he will spend less and he will spend he will spend, but his delta will be like -1, and here delta is going to -20, and his savings will be suppose 2 plus 2, and this person saving here will be, let's suppose, 100. So a great spender groups with the least bad spender. This will work, but if we suppose if there is a very bad spender -500, and here we don't have a, so like in comparison to this is not enough, so we will keep extending the groups, and this will be our sum. And suppose this is not enough to cover them. So it is better to leave this person. And we don't. Okay. I think we will have to start this from middle and keep clubbing. Least good spender. I am referring this them positive delta as good spender and them as negative delta as positive delta, negative delta as bad spenders. Least good spender with best bad spender. Hmm. And if we cannot club, if this is also very bad, then it is better to leave them and make groups of these positive only. So the minimum possible answer will be when no bad spender will go. Count of zeros deltas, count of zero deltas upon 2 plus count of positive deltas upon 2. Minimum possible answer. Case 1, when no bad spender goes. And now we will try to make the groups greedily. Okay. Hmm. I and J from middle is, I think, better than we here we are starting from. Earlier we were starting from the worst spender. Hmm. But now we will try to hmm, go with the good spenders. Okay. And let's see some test cases. Let's try with some test cases. Thinking, take this. What we can do is we can copy paste everything. And now think on this line which we thought and see how it fits on all of them. Correct answers are 2, 0, 1, 3, 1. So we saw this. So this, let's see on this. 54218 100. These pendings are okay. Bad spender, very bad spending. Zero delta, okay. Good spender, a very bad spender, okay. So deltas are delta is yi minus xi. So this is -4, -3, -2, 0, and this is 1, no 7, and this is -100. So we can, if we sort them in ascending order, sort delta in ASC order, and we have a -4, then -3, -2, 0. We'll have to, I think, keep 0 in order here also, because in that case count 0 deltas upon 2, this will result in answer is equal to 0 if we go with this. This is better. 0, 7. Or we can have some upper bound. We can find this 0 indexed by count all negative elements, then 0. We can also have upper bound, lower bound of 0. And then that will set I to here, and minus minus this iterator minus minus, we will have this j. I should be here and j should. Now we try to club. So his bad spender and some positive sum should be greater than negative sum, and we will not increment the negative sum. So we will extend this group here. Now their sum is 7. So plus 7 is greater than or minus 2. So we'll make a group, and here this here out of bound. So we terminate. And group count is 1. This is one of the possibilities, and we can also make one group of only these two. So our answer will be maximum of if we n minus starting j, start j upon 2. We'll have 0 waste index 0, 1, 2, 3, 4, 5. So n is 6 in this case. 6 minus our starting j will be here on 0. N minus j, 6 minus 4, 2. Okay, fine. Plus answer from 2-pointer approach. this will be because if we make some group here of only positive, is also possible. Two, three. Suppose this is -5 and this is +6. This will okay. -5 is less than 2, okay. We'll have this also as 2. So we extend it here. And this is till this point also -4 is less than next, positive is +4, negative is -5. We will not cover. We go to here. Now we will be able to cover, so we make them as one group. But here one more, the more efficient grouping will be this one. We send them and I try to cover his expenses with this first. This is a more appropriate grouping. In this group count is 1 here. This is group count equal to 2. So we can have in 2-pointer approach also we can have only positive deltas group. What we can do is we try to, earlier we started from this, then we go here, and if still the problem persists, we will make them a group. So positive deltas will move in window of 2. So positive deltas max grouping equal to 2. We will not be able to cover it, so now we will not try to extend this. We will make them and these two friends as an individual group, and we increment a j to a new group. Does this pass other cases also? Because we don't need the burden, okay, spending. Count 3 by 2. suppose this is 8 and this is 10. Here it is 8 and here it is 10. So now we will make this a group, and we should write it here. 8 and 10 are i's, j is here, I is here. This is not enough, so we move on to next. Now it's good, so we make these three a group. Answer is 3. Okay, so we try to extend days using gain and cover expenses using positive ones. Okay, so we got one case here. So good. We'll have to also revisit these per examples also. Let's see this one. We saw this one. Okay. And we started our thinking from this one. 1 4 1 2 4 2 2 3 4. So delta is 0 minus x minus 1. This is plus 2 0 minus 1 minus 2. Now we'll sort them. Minus 1 minus 2 minus 2 minus 1 minus 1 0 0 and plus 2. Okay. Here is I, here is, sorry, here is J, here is I. And negative, we cannot cover it this with 0, so we go here. And we are still not able to cover them. And now our positive delta group is size is 2. So we will make them an individual group. It is better to optimally do this than extending the group, because we can make them a group, so we will send them. Okay. Because essentially we are including them to increase the group count only, but these are then leading to the burden. These are becoming a burden, so we will leave them. And now group count will be 1, and we do not try to extend it further. We start from a new group plus 2, and plus 2 will be able to cover this man's expenses, so we will group them only. Now group count is 2 and we go out of bound, so answer is 2 3. Oh, and the answer is minus 3. Who is spending the money? 0 0 plus 2 minus 1 1 4 3 1 3 2 2 4 3 2. And this is plus 2. Yeah. We have 2 plus 2's. Hmm. So we make them a group and decrement our I, then also increment our j, and then we again see this is greater than this. So we make them a group and then go out of bound. So we exit. So I think this is good approach, and I think I should be writing the pseudocode because we have, I think, fine tuned our logic and refined it. Mhm. Let's see on the first test case and apply this thing. 83924 83924 5 3 4 5 delta. So -3 0 -8 +2 minus +1. This is +5. Sort them in ascending. See 0 here, -3 -8. Then we have 1 2 5. We start from middle, j here, I will be here. Sorry, j here, I here. Now we try to make the groups. This will be not covering, so we extend the size. Still now this will not be able to cover, but we reach the size. Maximum positive size is allowed is 2, so we make them a group. Group count is equal to 1. So we increment a j. Now we have made them a group. Let's show like this, and still we are not able to cover, so we extend the size and see the sum. Now the sum is positive, sum is 7, and this is -3, and so we will be able to make +7 is greater than -3 mod. So I will make the group and decrement this, increment this, and we go out of bound and do exit. So answer is 2. Okay, so I think I should write the pseudocode algorithm. What we will do is, and I think our solution will take n log n time due to sorting and everything. first we will do is calculate deltas. Make a sorted delta vector. This will take n log n. Second is we find the starting point from middle for I and j. So that will have, this will be pointing, j will be pointing to value greater than equal to 0, and I think we will have to use upper bound for it or lower bound. Lower bound 0. We'll use lower bound 0. A j is equal to lower bound of 0, lower bound in delta and 0. So j will be pointing to a value greater than equal to 0, and our I will be previous of j. And these will be our starting points are set now. Okay. So one of the answers is, answer 1 is, if we do not try to extend the groups, so n minus j, this starting point is answer n minus j upon 2, and our second answers will be from this grouping which we are simulating. Answer 2 will be while I is greater than equal to 0 and j is less than n, we will do this simulation to make the groups. We initialize a current group sum as delta j, current spending as delta I, current group as 1. Now if current group size positive group size, let's see, this is better. Positive size only is, I think, positive size. If positive size is greater than equal to 2, then we increase the group count plus plus and add j plus plus. And we set a current sum equal to 0. If we have a positive size is equal to 1. If else positive size is equal to 1, if current sum is greater than current spend even equal, we make the group. So group count plus plus current sum current sum will not be 0. Current sum current sum group count is incremented, then also increment the j. Also increment the j. Positive size is set to 1 again. Else we try to extend the positive group. Current sum, what we do is j plus plus. While we are doing this, we will have to check we don't go out of bounds everywhere. Mhm. This is becoming a messy loop. This can be done in a better way. J plus plus current sum plus equal to delta j a. We have to make these two as well. Okay. I think we don't need so many parameters. And delete them. This has become messy. What we can do is I set and j set. If a of I mod is greater than a of j, then we need to extend. We'll try to extend. If a of j if a of j plus 1 is greater than equal to a of I mod, then we can make this group count plus plus I minus minus j plus plus. Hmm. And we can go to next iteration. Else, if this is not the case, we'll make the positive delta group only. So we go j plus plus and group count plus plus, and we can safely go to next iteration. It's better to have this. Okay, this is the first case. If a of I is greater than a of j. Okay. Else, if a of j is greater than, will here it will be able to cover the expenses. So group count plus plus, and we do I minus minus j plus plus. And I think this is what I want to achieve. With this loop earlier it was become a lot of messy due to so many variables, but I think this is good because the only window of 2 is essential to us. So group count will only take, group size would have only take two values, 1 or 2, and we can handle this gracefully here. I think we should code this now. Answer is answer final is fifth step, maximum of answer 1, answer 2, and we return our answer. N CNN we will straight away make the delta vector, but delta I'll have to make x and y. Okay. X of n by n for int I. Xi is equal to e. This will be y. Now we will make our delta vector. Delta n for int I. Our delta I will be equal to yi minus xi, and then we sort the sort a delta vector. Delta dot. Okay. And then we go and find our j, initial j position, j start. J start will be a lower bound of 0, lower bound. So either it will be 0 or a positive value. Lower bound delta 0. And auto I start will be previous of j start. So this will point to a negative value always, and if there is no negative value then it will point to nothing. So first possible answer is int answer 1 is n minus minus lower bound then this will be our int delta dot again. Then this is j start minus 1. So our first is n minus j start upon 2. And then we start a loop while I is greater than equal to 0 and j is less than n. Int I is equal to I start initially, int j is equal to j start initially, and now we try to make the groups if A absolute AI delta I is greater than delta j. J plus 1. Otherwise we can go out of bound. Int group count equal to 0 initially. Plus plus I minus minus j plus plus else plus plus So our group count will store the second answer and our final answer will be maximum of answer 1 comma group system failed 3 2 first test case also was 3. Is the first test case. So delta is -3 0 -8 +2 +1 +5. We sort in ascending order, then -8 +3 0 +1 2 5. So maximum one of the answer is here will be a j, here a I, n is 6 6 minus 0 1 2 3 4 5 n minus 2 on 2 this will be 4 on 2 is 2. Okay, one of the answers. Now we do the grouping. Okay, this is not enough, so we implement. Still not enough, so we leave them and make them a group and start with a new one. Not enough, so we make now enough, so we make them a group. So answer should be 2 only according to my logic. Why it is 3? Then given something in my code. Let's see this as separate. Expected outcome is 2. See out I start. Now 2 is a J start, it is correct, and is 2 will be a J start. Okay, this is correct. Answer 1 is okay. N minus 6 minus 2 4 upon 2 okay, is 2. Count 0. Our J can go till here. J can go till last. And before extending the group, we will have to check this. If j plus 1 is less than n, and then we will extend the group object. Then while this is causing the problem. Loop is incorrect. We should write this again. First, we will have to check that whether I have the second element or not. We can extend our window or not. G plus 1 is less than n. Then only here we need to extend the group to cover the expense. If this is also the case, then if delta I in delta j plus delta j plus 1 is greater than equal to delta absolute delta of I, then this is good, else j plus equal to 2, because we made those two as group, and then group count plus plus. Okay, yeah, plus equal to 2 was the catch. Quantity. Okay. Then we made the group, so we also go here j plus equal to 2 I minus minus, then group count also 2 plus plus. I think this is good now. Let's see this. Yes, okay. Damn it. J plus 1. Else low is if this is not true. If this is true, we cannot cover the expense, and we cannot also extend our window, and we break simply. And this is 2 0 1. In this test case is the third last. Expected output is 3. Logic is simple, but I think I'm messing up in the code. actually 6. This one was plus 3. This is plus 1 plus 1 plus 1 plus 1 minus 1 minus 1, and this is also plus 1. So we sort them. Earlier I think I did some mistake there. Minus 1, then 1, 1, 1, 4 times, okay, and 3, and is equal to 6, 1, 2, 3, 6 minus 5, 1, 10, 7. First we can make all positive groups. So J start here, I start here, and so 6 minus 1 upon 2 comes out to be 5 upon 2 is equal to 2. One of the answers. Oh, okay. Good. So we are terminating our loop here only. Then what we can do is we can okay, we can check this got matched and we go out of bound. Okay, we increment our group by 1 and we then go out of bound. So what we can do is we can then apply the same formula out of the loop and we can check for this condition. Okay, so now if I is less than 0 and j is still less than n, what we can do is we can increment our group count plus equal n minus j upon 2 times. All spenders they covered easy. This should work. All okay. I think these will be edge cases in this code. J plus equal to if I early return then n minus j upon 2. Let's submit. Wrong answer. fifth number differs. Okay. Expected to found one. Fifth number, fifth test case. Okay. 1, 2, 3, 4, 5. Expected is 2. What we are getting? Let's dry run this one. I think the approach is correct, but some bugs in code. 7, 3, 5, 3, 2, 5. Delta -1, 0, +1, -5, +2. Expected is 2. And now we sort them: -1, -5, 0, 1, 2. Okay. So what we have done here is we should have made this group and then we should group this. Then answer will be 2. But here we did -5. What our code did is he made this a group. Then it was not able to form any group. This is difficult to tackle now. Groups of 2. If we are able to cover it, just if we are just able to cover it also, then we remove this. Will this be correct? Is this correct? Just able to manage. Lose a spender, which can be in future result in okay. I think this will be okay. Improvement. Should be greater than not equal, because then Spender is lost. Which could have been used in future. Which could be used by future. Positive deltas. Because they are. Let's see what happens. This should work. I think I should end this stream because it has been nearly 2 hours, and I think this is the correct approach of the question, but the translation of the idea into code is leading to some bugs. 18th test case. I will have to track it down. 1, 2, 3, 4, 6, 8, 9, 10, 9, 16, 17, 18. Let's just see this for 5 minutes, then submit it. Try to fix it as soon as possible. And submit it. If it works good, if it does not work, I end the stream. Expected 3. Plus 7, 0, plus 7, plus 8. We have great, we can easily cover spenders here. You can see 0, 7, 7 here, minus 4, minus 2. J here, I here. One of the answer is initial is 4 on 2, which is 2. Is the correct answer. Now we try to group them. They are not covering here. Now we are able to cover them. So now we go here. And we make this a group. Then decrement, increment, go out of bound. We try to make this a group, but it is one person only, so we cannot make them. So how is the answer 3? My code is correct then, and there is something with my approach then. This, how it's possible? Okay, okay. He's covering mini spenders with one. He's covering so that we can make two groups. What he can do is he can, if we go with this group 8 minus 4 minus 2, he can cover them. Then 3 people are left. 3 people can form at max one group. We'll have to take this and extend this. And then also, how is the answer? 3 is not possible. How the answer is 3? Three is not possible in this case. Three means each of 2. Not possible. Answer 3 is not possible, I think. How this is 3? I will ask this to the what is the possible group? I will not ask the solution, I will just ask him what is the correct answer for this test case. Don't give me any solution or hint of approach. Just tell me what is correct grouping for this test case. Oh, it is possible to make the answer 3, because if 3 is the answer, then 2 people are there in each group, then 6 are total people. There are negative people also. Group 1, friend 1 and friend 5. Total friend 1, 3 days. Friend 1 and friend 5. 1, 2. 1, 1 2 3 4 5 6. So he made the group of 1 5 minus 2 with plus 7. Friend 2 and friend 6. 2 with 6 minus 4 and 8. Okay. 3 and 4. 3 4 7 0 delta minus 2 with plus 7. I think I should end the stream. I will see into this how we can translate this into our existing approach. And I think it's time to say goodbye.